When we're adding fractions, what we're actually doing is adding the numerators, the top parts, and keeping the denominators the same. So an easy example would be something like 2 over 3 plus 3 over 3. The answer, we keep the denominator the same, 2 plus 3 is 5 over 3, which is, of course, an improper fraction. So I could change this because I know that 3 over 3 is a whole thing, so that would become 1 whole, and I have 2 more left over, so it would be 1 and 2/3. This is quite an easy example because the denominators are already the same. But what happens if our denominators are different? A slightly more difficult example might be something like this. 1/4 plus 2/8. So in order to add, we have to have the same denominators. Well, if I look at this, I can see that these two numbers have something in common. They have a common multiple. So I can take 8 and divide it by 2 and end up with a denominator of 4. So I'm going to leave 1/4 alone, and I'm going to work on 2/8 for a second over on the side. So 2/8, I can create an equivalent fraction with a denominator of 4. 8 divided by 2 is 4, and 2 divided by 2 is 1. So 2/8 is actually the same as 1/4. So over here in my addition, my next line looks like this. 1/4 plus, well, since 2/8 is the same as 1/4, I just substitute 1/4 in instead of 2/8. And then my answer, 1 plus 1 is 2, and I keep the bottom the same. So my answer is 2/4. When I look at this, I see that I can actually make this smaller. I can put this fraction into simpler terms. So 4 and 2, well, they have multiples that work together. So 4 divided by 2 is 2, and 2 divided by 2 is 1. So 2 over 4 has an equivalent fraction of 1/2, which is simpler terms, which means that each of the numbers is smaller. Let's try another example. 1 over 8 plus 2 over 3. In order to do this, again, I have to find a common denominator. Common denominator means that I have to find equivalent fractions with the same denominator for each of these two fractions. So when I look at this, I can run the multiples of 8 and the multiples of 3 and see if I can find one that's common. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And I can keep going if I need to. Then I do the multiples of 3. 3 times 1 is 3. Well, there's nothing that matches there. 3 times 2 is 6. Still no match. 3 times 3 is 9. Nothing. 3 times 4 is 12. Still nothing. I continue writing the multiples of 3 down. Until, there's a match. 24 and 24. So this is 1, 2, 3, which means 8 times 3 is 24. And here, this is 1, 2, 3, 4, 5, 6, 7, 8. That means 3 times 8 is 24. I can do it this way whenever I'm not sure. Or the shortcut is, well, the lowest one is actually 8 times 3, which are the two denominators that are here. A foolproof way to figure out a common multiple for denominators that you're not sure about is just to multiply them together. My lowest common multiple is 24, and that becomes my denominator for the problem. So, now that I know that I'm using 24 as my common denominator, I have to make equivalent fractions for 1 over 8 and equivalent fractions for 2/3 with a denominator of 24. So I go 1 over 8 equals something over 24. And I know 8 times 3 is 24, so 1 times 3 has to be 3. I do the same thing for 2/3. So my common denominator is 24, So I need an equivalent fraction. 3 times 8 is 24. 2 times 8, 16. So now I have these two equivalent fractions that I can now use in my problem. So since 1 over 8 is equal to 3 over 24, I substitute that in. 3 over 24. And 2 over 3 is equal to 16 over 24. I substitute that in. Then I keep my denominator the same, and I add the tops. 16 plus 3, 19 over 24 is the answer. Now all I have to do is find the answer. My denominator stays the same, so it stays 12, and I go 3 plus 4, and I get 7.